Hello students, today we are going to study about the trial on hydraulic trailer unit. So under this experiment we are going to assemble three different kinds of circuit, namely to study and perform regenerative circuit, then second to study and perform a speed control circuit, and third is to study and perform sequencing circuit. So speed control circuit we are going to perform by use of flow control valve, and uh, sequencing circuit we are going to perform by using pressure control valve. Okay, so first we are going to see what is the normal hydraulic circuit. That means a usual hydraulic circuit in which there is no regeneration. Okay, so let us study that from a pump the fluid comes to this P port. Okay, from P port it comes to this 4/3 direction control valve. Okay, so from P the fluid goes to this manifold. Okay, from manifold you could see the fluid comes to this P port over here. Now A and B port of this valve are connected to individual end of the actuator. Like A port is connected to the cap end side of the actuator, and B port is connected to the rod end side of the actuator. So because of this you could see there is no regeneration in this particular circuit. Now we are going to see this particular circuit in operation. Now when I turn it on and also you can see that during forward stroke the speed is slow, but during reverse now what we observed here is that during forward stroke the speed is less, and during reverse stroke of the actuator the speed is more. Now why it is like that? Because we all know that this is a double acting actuator and the effective area for the same discharge is more when the fluid act on the cap end side of the actuator, because of which the forward stroke is slow, but when the fluid is going to the rod end side of the actuator, the effective area is less but the discharge is same. So because of which you will have a faster retraction. Usually in industrial operation we require a faster forward movement and faster forward movement. So for that purpose, usually in industry, in many machines, regenerative circuits are used. So in further video, we are going to study about assembly of regenerative circuit. Thank you. Okay, so we are going to study a regenerative circuit now, how to assemble it. Now from P port, the hydraulic oil pressure fluid will go to this manifold. Okay, so here from this manifold you could see it's a junction point actually, so through which many flows will emerge. So now from this manifold the fluid goes to first it goes to the P port. Okay, so from here you could see the fluid is coming to P port in the valve. Okay, it is connected over here, P port. Okay, now the A port or the actuator port of the valve is connected to the cap end side of the double acting actuator. Okay, now since in regenerative circuit we know that the fluid which is there at the rod end side of the actuator is again fed to the flow of the pump in order to increase the discharge on the cap end side of the actuator, because of which the forward stroke will be much more faster than the reverse stroke. So you could see that from one port of this particular wall port is the actuator is blocked. This B is blocked actually. Okay, so now here you could see that the fluid which is there in the cap end side of the actuator is coming back through this hose again to the manifold. Okay, so it will get mixed with the incoming flow or incoming fluid which is going to the cap end side of the actuator, because of which this particular actuator will move in a forward direction uh, more quickly than the reverse direction. Okay, so we are going to see its demo in further video. Okay students, so this is our hydraulic trainer unit setup at our IFP lab. So what we have here is that, as we have studied in earlier practical, that we have a hydraulic pump which is driven by an electric motor, and there is a reservoir. Okay, and at the back side of this particular trainer unit there are pipes through which the hydraulic fluid enters into different manifolds. Okay, so here we have P port. Okay, so P stands for pressure port, so this is a manifold actually. So from P the fluid goes to the different components of the circuit. Now we are going to study a regenerative circuit. Now in regenerative circuit we have this actuator. This is a double acting actuator. Then we are having this 4x3 direction control valve which is manually operated. You could see that here the ports are mentioned like P, A, B and T. So this will help us to assemble the circuit whenever we are going to work on this particular hydraulic trainer. Okay, so we have started the trainer unit. Now you can see that we will keep this valve under neutral position first. Now the time which is required for forward stroke is being recorded. Now the time which is required for reverse or retraction is recorded. Start. So this particular movement, when we measure this movement, we require less than 5 seconds for forward stroke, but more than 6 seconds for the reverse stroke. That means the forward stroke has been made faster because of the regenerative action, because the fluid which is trapped at the rod end side of the actuator is again fed back to the cap end side of the actuator with the help of regenerative hose. Now in this particular circuit, the regenerative hose is this one. Okay, so the hose which connects the rod end side of the actuator to the manifold again. So this hose will give you a regenerative action. Thank you. Now we are going to study about speed control circuit. Now under speed control circuit, we have two different types of circuit. First is meter in type and second is meter out type. Now metering in, that means we are controlling the hydraulic fluid which is going inside the actuator. So for that we need to place a flow control valve between a direction control valve and actuator, such that the fluid which is coming from the actuator P port of the direction control valve will go to the inlet of the flow control valve. So this is a flow control valve, and outlet of the flow control valve is connected to the actuator. So by this particular circuit we are going to control the hydraulic fluid which is going inside the actuator, because of which it is called the metering in type. Okay, now from the rod end side of the actuator is connected to the B port. Okay, T is connected to tank, P is connected to the manifold. From there the hydraulic fluid will come to this particular circuit at higher pressure. Okay, and B from one of the actuator port. Okay, we need to supply the hydraulic fluid to this flow control valve, and through flow control valve the fluid goes to the actuator. So this is how the metering in type of hydraulic circuit works. So we'll see this circuit in operation. So if I make it on, now forward stroke, now in this particular circuit we have fully opened this particular flow control valve. Okay, so if I close this flow control valve, what we observe is that the forward stroke of the cylinder is going to be much more slow than previous. Okay, so let us start it and I'll show you. It will be much more slower than the normal working of the circuit. Now I close the flow control valve and I restricted the flow which is going towards the actuator. So here what we observe is that forward stroke is much more slow now because I restricted the flow which is going towards the actuator using metering in type of arrangement. Now we are going to study meter out type of speed control arrangement for the hydraulic circuit. So now here what you observe is that under meter out circuit we are going to control the hydraulic fluid which is coming out from the actuator. That is, the flow control valve is placed between actuator and tank. Okay, so that will create a meter out type of arrangement. So here in this particular circuit what we observe is that the pressure P, that is hydraulic fluid P from the pump, goes to manifold. From manifold it comes to P port of this 4x3 direction control valve. Okay, now from B port of the actuator the fluid goes to the rod end side of the B port of the direction control valve. The fluid goes to the rod end side of the actuator. Okay, so reverse motion of this actuator is normal. Okay, but the fluid which is trapped at the cap end side of the actuator is forced to pass through the flow control valve. Okay, that is, the fluid which is coming out from the actuator has to pass from this flow control valve. Okay, from the outlet of the flow control valve the fluid goes to the A port over here. A port, A and T is internally connected during the forward stroke of the cylinder, because of which you will find that the metering in of the forward metering out of the forward stroke of this particular actuator is going to take place. That is, we are going to control the fluid which is coming out from the actuator. That is why it is called the metering out type of arrangement. So we are going to study, or we are going to see this circuit in operation. So here what we have done is that we have metered the flow which is coming out from the actuator during the forward stroke. Okay, because of which the forward stroke has been slow. So under same situation, under previously video what we have seen is that we are going to control the speed of forward stroke of the actuator by putting metering in type of arrangement, and here we are putting metering out type of arrangement and we are achieving the same speed control. Now which is more efficient, metering in type or metering in out type, which is more efficient, that you have already seen in the theory class, but the purpose of this video is to demonstrate you the combination of metering in and metering out type, that is various type of speed control circuits. Thank you.